question here. Drew the picture for it already. The projectile makes 60 degrees with the horizontal, and this plane it's projected up makes an angle of 45 degrees. So the angle with respect to the plane then the projectile is fired at is 15 degrees to make the total of 60, and it's launched at a speed of 50 meters per second. What's the time taken to reach the maximum height above the plane? So that would be like the time for it to get here, which is the maximum height above the plane. So the hint here I give you is to set up the x and the y axis so that the x-axis is along the plane and the y-axis is perpendicular to the plane. Just before I do that, actually, let me just extend this out a little bit more here, and extend this out a little bit more here, and just draw in the fact that gravity is downwards like this at g meters per second squared, 9.81 meters per second squared, I mean. Okay, so the trick here is to rotate so that you're looking at it with the surface of the plane lying on the x horizontal axis like this, and then this would be like the y-axis here. Now, this is actually a nice little trick because it gives us a way to deal with the angle that it's projected on, the fact that it's projected on a non-horizontal ground quite nicely. So everything is still the same here. So you could kind of, for the moment, almost forget about the fact that it's on a plane. This component here will be 50 cos 15, and then this component here will be 50 sine 15, and it looks like a regular problem at the moment, but the difference now is that the G no longer in this frame, the G no longer acts vertically down along the y-axis. It's actually at an angle, so the G as well needs to be resolved. Now, if that's 45 degrees, and if we if you want, you can think of that then as 90 minus 45 degrees, or if that's 45, this angle here is 45, and again, this comes from a bit of geometry. So these two lines here, this part and the G are parallel, and this line here is at right angles, so whatever angle is here, then if I draw one straight down here, this I'm not going to mess this angle here is the same as this angle here, and the logic is that this is a triangle, this is 90 degrees, so if this is 90, this angle here, we know this will be 90 minus this angle, so this one will be 90 minus 90 minus that angle, so in other words that angle there. So a little bit tricky maybe to figure out the angle, but that angle there is 45, so this is G cos 45 this way, and this is G sine 45 that way. And the question is, what is the time taken to reach the maximum height? So this is the usual UVATS. So the U is 50 sine 15, the V is 0, the A is minus G cos 45, which is minus G over root 2. The T we don't know is what we want, and the S we don't know and is what we want. So if we go with V equals U plus A T, we can get the T. So let's have a look here. 50 sine 15, times square root 2 divided by 9.81. So the time is 1.866 seconds. That's the answer for the first part. 1.866 seconds. And then now the S, we can go with S equals U T, and then a half A T squared. So then the S equals 9.81 over square root 2 times answer squared. Actually, yeah, U, I left out the T here. U T, and then minus a half G over root 2. Okay. 12.07 meters is the maximum height above the plane. What is the time of flight? So time of flight, everything is kind of the same. Let me go backwards. The little difference is now the V is not 0, and it's the S that's 0. So we get S equals U T, and then a half A T squared, and we'll take the T to be bigger than 0, so we can divide through by the T, and we'll get T equals 50 sine 15, let's see, times 2 times square root 2 divided by G, 3.73 seconds. Time of flight. What is the range? Okay, so the range we have to look horizontally, so that would be U equals 50 cos 15. The V, we don't know. The A horizontally is decelerating with G sine 45, which is minus G over root 2. T we don't know, and S is what we want. So we'll go with S equals U T. Actually, sorry, we do know T, 3.73. S equals U T plus a half A T squared. So let's see, that would be 50 cos 15 UT, and then a half A times T squared. UT, and then a half A T squared. Okay, so that comes in at 131.9 meters. That's the range. What is the final velocity of the projectile just prior to impact? So that is the V in both cases. So V will be U plus A T, and the same thing here. U, and then the A and the T, and actually we know the T in both cases, it's 3.73. So the Vx and the Vy will be 50 sine 15 minus G over root 2 times 3.73. So let me see, this is Vy, which should be a negative, and it is, minus 12.93. And then Vx, I think the only difference is actually that this is a cos. Yeah. 22.42. It's still heading to the right. Positive 22.42 meters per second. Okay. What is the final speed? So the speed, just using our usual magnitude formula here, square root Vx squared plus Vy squared. And that comes in at 25.9 meters per second. And lastly, at what angle does it hit the plane? So, horizontally it's going at a 22.43, and then vertically, or in the y direction I should say, it's going down at 12.93. So it's going into the plane at this angle, which will be tan inverse 12.93 over 22.43. So it's heading into the plane at an angle of 30 degrees. 30 degrees. 30 degrees into the plane. Okay, that was a tricky one.